Tune into this week's Xamarin Show where I have my good friend Alexey on talking about memory management for your applications. So tune in. Welcome back, everyone, to the Xamarin Show. I'm your host, James Montemagno, and today I have my best friend in the entire world, Alexey, with me. How's it going, buddy?
I'm good. How about you?
I'm doing fantastic. It's a beautiful day here in Redmond, Washington, every day. Now, you're from our mobile customer advisory team, is that correct?
That is correct.
So what does that mean?
It means that we work with our clients and we advise them, obviously. But mostly we work with developers and see how they use tools, how they work with our Xamarin tooling, and what are the common pitfalls they face with.
Perfect.
And today I want to talk about one of them is memory management.
Ah, gotcha. Yeah, it's very important because we often talk about all the cool, fancy features you can do, but we wanted to have this best practices series because you run into trouble, right? It happens. It's so easy to do. And memory management, honestly, I'm a noob. I really don't know. I'm just like, they're going to kill my app in 5 seconds. It doesn't matter, right? But I shouldn't think that way.
That is true, and that's what we see because nobody cares about the memory management. We have so much memory, and you never check the memory. When was the last time you checked your app memory usage?
The last time I got a crash, actually I had a very good example of this. I'll tell you this. This is a real world example. I got a bug that said, in Xamarin Essentials, it says, when I call this method 20,000 times, my app crashes. And it was because I wasn't properly disposing of a native Android object, a window, a display. So what was happening is I would keep creating it and it would never get garbage collected ever because I was never disposing of it.
And that's what we're going to talk about today.
Yes. Awesome. Let's do it. What do you have for us?
So we have this small, simple app with 2 windows and main screen and detail screen. That's a very common pattern, navigation, UI navigation controller. And this plain iOS, Xamarin iOS application, right? Okay. What we're going to do is introduce memory leaks in many different ways. But first I want to talk about differences from native world and managed world performance and memory. Okay. So whenever you have a process, operating system giving you a memory chunk. And you should be aware about that because once you run out of memory, your app crashes or operating system kills it. Yeah. And managed memory, our Xamarin Mono getting this small piece of this memory, and that's when we should be cautious about how we use that piece as well. Okay. So you still should be aware about native memory, and now once you work with Xamarin, also aware about managed part.
Got it. So you have native memory, iOS, Android, bits and pieces, .NET, managed memory.
That's right.
Perfect.
Whenever you create an object and you create, let's say, UI button, you actually create a native UI button and managed UI button class. They have different memory impact. They could cause different memory issues because there is also a native way to collect the garbage and managed way. In Mono, we use Mono single generation garbage collector. In native world, iOS use ARC, Android use its own garbage collector, but they should work together side by side. And we should help them because you can introduce issues by using that.
Got it.
So the first and the most simple approach to introduce a memory issues, it's a subscription without unsubscription. Whenever you have garbage collector should know when there is a garbage. But how could he know? It should be able to build a reachability tree, graph, and it starts from roots. And our static events, static variables, or static events, or thread locals, they all reachable roots, and garbage collector treats them as not garbage. So whenever you subscribe like this, let's take a connectivity plugin. I know, James, you're familiar with this plugin?
I am, yes, very much so. I do like that. And here we're just subscribing to an event. And there could be any events, a clicked event, sensor change event, basically anything ever in .NET.
Yes, right. It's specific not only to Xamarin. It's any static event in .NET, and connectivity here is just an example. What I'm trying to say, it could be any static event or any singleton provided event. So whenever we subscribe like that, and let's say we have this small little piece of connectivity change event handler, we introduce a small memory leak. It is small because our view is pretty simple and lightweight, but it's a memory leak.
So it's a memory leak. Why, though?
because this connectivity and connectivity change event is a static reference for our garbage collector. Once our garbage collector is trying to identify if it's a garbage or not, it is not, because connectivity change event has a reference to this handler. And this handler actually handles the reference to our details view controller.
Oh, I see. Got it. So we've created this event inside of this view controller, and I've subscribed. I've never unsubscribed. So it always has this reference immediately. So garbage collector says, hey, what's available? And it goes, you can't have that.
That is correct.
Basically.
Yep.
All right, I want to make sure that that is correct, because I believe that's how it works in my mind. I want to make sure I'm right.
The single task garbage collector does is to deallocate memory, and to do that properly, garbage collector should know how to properly identify if it's garbage or not.
Got it.
So to build that reachability tree, garbage collector uses static roots or just roots, and static events or any static property is one of the roots. Also local variables, a lot of other stuff.
Got it.
So let me just run it and show how it works. Do you think we will see any difference?
I don't know. I mean, hopefully not, because it's so simple, is what I'm thinking. Now, my fear, though, is that since we're registering over and over and over again, if we do change events, we're probably going to get a lot of events.
Yeah, let's verify it. So I've moved to details page. I'm going to disconnect my Wi-Fi now.
And here we're using the iOS simulator, so it's actually using the machine's internet.
Yes. We just got an event here that our connectivity changed. Let's go back a few times.
Uh-oh.
A few more times. And I'm back on the main page, and I'm not deallocating anything right now. And I assume that my details page are no longer there, right?
Yeah.
My subscription handler shouldn't work because I didn't do anything. Let's turn on the Wi-Fi.
Okay, so we actually created this connectivity change on the second page.
Second page, right?
But I'm on the first page.
Yes. So we do not expect our handler to work, but look what we got. We just got 4 handlers running our code. And it could be any code, updating database, saving settings, whatever. And the issue here, not only with memory management, because it does take some memory, it's also an issue because we have some code to be executed as well.
And then does that mean that the details page, now it can never be garbage collected? So now I just have this details page always in memory.
Unfortunately, yes.
Oh my goodness, that's bad.
That's bad. And as a developers, we not always see that. As a user, I see my app crashes like once a week, whatever. I'll just restart it and continue to use it. And that's why it's not reported. It's not taken very seriously. But it is an issue, especially if you get a huge image there, which affects your memory. So I'm going to uncomment this line of code, which actually adds some memory load here. And it is loading an image from the internet. We just taken a random image. Let me show that it's truly random. Let's see what we get here. I'm always worried about that. OK. So we have this random image, and that's what we're going to load in our app every time we go into details page.
OK.
Let me show it here.
And this is totally something that would always happen, right? Because you go to a details page, probably load some information, might be pulling some information from a database on that screen, and that could be bad.
Imagine yourself, you're using Instagram app. You have a details page there. You tap on photo, go into details, going back, go check another photo, go into details, going back, and in a week your app crashes, and nobody knows why. And that's when memory issues could come into play.
Gotcha.
And I won't show you that memory leak is still there, because I want to show you the profiler, how you can identify these issues. And to identify these issues, you have a few tools. First of all, it's native tools. iOS provides instruments. And second one is managed tool, which is Xamarin Profiler.
Gotcha.
Why do you think we need both?
Well, they do different things?
Yeah, actually, all because of this image. Remember I talked about that? They actually can know about only its own part. So Xamarin Profiler knows nothing about the memory native objects created there. And native instruments doesn't know about managed memory. It just says there is some chunk of object created. When Mono creates an object, it still binds it somehow to native objects. So Those you will be able to see, but all the rest won't be.
Okay, cool.
So let's see the Xamarin Profiler. It is easier to comprehend at the beginning, and it also shows you nice namespace and like naming, so you can identify your objects.
Cool.
There is a small button, Run and Start Profiling here. You need an enterprise license to do that, but it's very convenient, and I encourage you to do that. So once you do that, it actually builds the app with some additional metadata and code embedded into the app, so we could see and track the objects.
Now, one thing while this is building and deploying is we're running on a simulator, which means it has the full horsepower of this.
Mm-hmm.
Is it OK that I'm doing it and profiling it on my device, or is it better to do it on a physical iPhone, for instance?
That's a good question, because you can do different kind of profiling.
Oh, interesting.
If you profile in CPU, it's not a good idea to do it on simulator because you haven't the full power of the device. But if you do a memory profiler and allocation, you will get the same issues on simulator and on device.
Perfect.
And I like doing it on the laptop because it just starts faster. It does not translate the code into native instructions and just simulates and run instantly.
Perfect.
So, and whenever you do memory profiling, you run apps so many times, so you're gonna like it. Let me do the same test. So I've opened the details page once, and you see this small peak here.
Boop.
It means that we increased our memory usage significantly. But you don't see this memory increase here. It's still like the biggest object is system string somewhere here. Let me do it a few more times. I will increase it again. You will see the spike here,
Boop.
but you don't see any spike here, which means that we allocating something in native memory. It does not reflect it in managed world, but we see the total memory is growing and not deallocating, which is the most important thing.
I see.
We came back.
See.
We do a snapshot. Memory snapshot actually runs a garbage collection on managed side. So we did a snapshot. I'll do another one. I'll explain it later to deal with the finalization queue. But basically, now it's clean memory. We make sure that our garbage collector already ran and deallocated all the required objects. And we still see the memory is there, so it didn't went down. To know what is going on here, we just go here and use the filter button. We're trying to identify only R objects, and I also want to see only live objects here. So I hit this apply button, and voila, we see two details controller hanging in memory, even though I don't have details page currently in place.
Super simple. So you said, find everything in my namespace, filter down on that, and literally what we see here is detailed view controller 2.
Yeah.
But it should be gone.
I would start with the biggest objects you have, and it's pages. And it is true for Android as well. You just search for activities, view models, or whatever. Because once you have a view model hanging there, it starts to link all the other objects.
Gotcha.
All the services, all the bindings will hold the UIs, and you will get a lot of memory used. Let me show that it is true. I'll open it one more time, hit the snapshot. We see 3 instances here. I'm going back, hitting snapshot, and it stays in memory.
Gotcha.
So let's fix this memory issue.
I'm ready.
How would you fix that?
Well, the first thing is
this is a details page, so we need to unsubscribe at some event.
Gotcha. Okay. So the real issue here is that I've subscribed to an event.
Yes.
And then we should unsubscribe, right?
That is correct.
Yeah.
And this is a good practice. Whenever you see this plus equal, you just search if there is a minus equal. If it's not, you should introduce that.
Got it.
And this is first indication that you have a memory leak.
Got
the
it.
only exception is when you subscribing on the main page, like our main page here, and you sure that this page won't be able to go away anytime soon.
Yeah, or maybe you have it at your app delegate level, so you're like, I actually want this to be a global event for all times, but also maybe when your app goes into the background, you should also unsubscribe.
That's true.
Yeah.
Not to execute.
So now you're saying when it appears, we'll subscribe and disappear, unsubscribed, and then you remove the one up top, correct?
Yes, I removed from
Gotcha.
deep load because we want to run it every time we appear and every time we disappear. And plus equal to subscribe, minus equal to unsubscribe. Nothing complicated. Just want to make sure we don't need any of these events once view goes away.
Okay, cool.
So I'm doing the same stuff, going to details. showing that it is true. Taking snapshot, filter into my events. Sorry, misclicked. And let's see on the live objects. We should see details because we're currently on details page. We're going back. We hit a snapshot. And what we expect here, first garbage collection actually put this object into finalization queue. But second should kill one. Oh, probably third one. Sometimes it's third one. Yeah.
It's gone.
Yes. So let me talk about finalization queue in a sec. But for now, the idea is that we lost our details queue, and now memory usage went down.
Beautiful.
That's how we fix memory leaks.
Yeah. If you subscribe to events, unsubscribe from events.
Yes. Basic rule of thumb.
And that's really funny too, because one, it caused two issues, right? We saw that you were keeping it alive because you have these events keep going, so now you're firing them multiple times. But also, anything on that page is going to be left in memory.
That's right. That's why we added a heavy image, and it's still in the memory.
Got it.
Let me show you instruments. So I'm going to introduce back our memory leak.
Sure.
Just removing unsubscribe event. I'm going to deploy it to my simulator. And instruments works fairly easy. You pick the target from the simulator and the app, and that is it. That's all you need to start the instruments profiler. Even though it's Xamarin app, you can start it right from the instruments, which knows nothing about Xamarin.
Where does instruments come from?
Apple. It's an Apple tool, comes with Xcode, and it has a lot of tooling inside of it.
So it's just built in because you already have Xcode installed, so everybody has this.
And it's free.
It's free, cool. So anybody can use this right now today?
Yes, yes.
Perfect. Yeah.
And you can actually see these activities. Even though those created by managed world, like details view activity, it is still represented by a native object.
Got it.
So let's look for that object, right? We call it details view controller. Let me create a few of them.
This is actually really cool because I've never used instruments. Shh, don't tell anybody. 8 years, and I don't think everyone's given me a detail. So it exists.
Yes, it exists.
That makes sense, right? Because Xamarin is native, so it creates a native object.
Yes.
Yeah.
You don't need to do a memory snapshots here because we don't have garbage collection here. iOS uses ARC, which is automatic reference counter. Basically, whenever you create an object, it increments a counter. Whenever you don't use or it goes away from the scope of usage, it decrements the counter. Once counter is 0, the object is garbage.
Makes
and
sense.
it could be collected. So it's fairly easy to start the instruments with the app just by clicking this button. It starts the app, it shows you the memory usage here, and let's open the details page.
Gotcha. Instruments comes from Apple?
Instruments comes from Apple. It's a free tool from Apple. You can use it right now.
Oh, cool.
And you see we also have this memory footprint right here once we open details page. Let's open it one more time.
So this is very similar to the Xamarin Profiler, but this is going to be showing us like the native stack for all intents and purposes.
That's right. And unfortunately, it knows nothing about Xamarin and managed world, so you won't be able to see your managed object created. So you see the spike, and you see it doesn't go away. So let me do it third time, and show the objects. So let's see. There is a small filter button. We go to all allocations here, and hit the details here.
Ah, okay.
We see 3 pages right here. They're all in memory, and they allocate in memory. I won't be showing how we deallocate it because it's same fix. We just unsubscribe. Managed world unsubscribes from the object considered to be garbage.
Got it.
Then our garbage collector collects that information. Then native can collect because nothing from managed world already holding to that.
Makes sense. Cool. So very much the same fix, but another way to detect it.
That's right.
Cool.
So this is about differences between managed and native world. My next examples will be mostly about managed world because you can introduce issue in any, and it's not related to Xamarin. Like you said, it could be subscribing to static event could introduce issue even anywhere.
Yeah.
So next thing is about subscription and without unsubscriptions. But in this case, we actually subscribing without implicitly. We don't use plus equal, so it's harder to find. And in this case, with the notification center, trying to identify whenever our app is rotated. And we add in this observer. This is a singleton default center. We're saying that I want to get any information whenever orientation changed, and here's my handler to that.
Got it.
The handler itself, it's fairly easy. We'll do nothing there. We'll just print it to debug.
Got it.
And let me remove the connectivity stuff because we want to introduce different kind of memory issue. I also comment out our image because we don't need to show the memory footprint. It is there. We will experiment just with UI view controllers and views.
Very cool. So this is very, very similar, but this pattern, you could be subscribing, maybe even passing in an action, or in this case, like this kind of what it does. It says, here's your callback. Delegates are very similar, I think, to this pattern. So this is something I'm used to as well.
That's right.
Yeah.
That's right. And that was the main idea, because when you subscribe in, you pass in the reference to the UI view controller as well. This is just different way to pass the reference. It's not that obvious sometimes. So we have our subscription. It's running here, running just once. Let's close and open it again. And now we have it doubled. Let me clear to show you this. Rotating once, getting two. Which means we have some UI view controller hanging in memory while still processing the first one.
Got it.
It could be an issue if you have some database update logic or HTTP requests over time, like in a day of use. Your app is not killed. You deactivate, reactivate. It will have all these views still in memory, and in a week it could crash.
Yeah.
So how to fix that? Very easy.
I assume that you unsubscribe.
That's right. That's harder to unsubscribe because you don't have plus equal. Let me show also what you actually send in here. So when you subscribe, you pass in not the like a method name. You actually pass in an action. And compiler doing a great job of hiding that and making our lives easier, right?
Because compiler is very nice.
Very nice to us. That's why we like to be developers. So it actually asks for action with NS notification. So I'm setting NS notification here, and then using this notation, passing this object. So instead of the method name, kind of, we actually pass in an action, an object, which holds the reference to this and metadata on how to call the method. So we don't pass the method. It's just a reference to method. In our case, the most important part, we pass in this reference, which is a UI view controller, and that's why it holds in memory.
Oh, got it. That
Okay.
makes sense. Yep.
I won't be showing the details because memory leak is still there because we saw this thing to save some time, and I want to focus on the worst case scenario, which you should be aware of when native world doesn't place nicely with the managed world.
Okay, gotcha. When the two worlds collide.
That's correct, because whenever I have managed object created and there is a native object created and ARC trying to deallocate native object, our managed world thinks, oh, I'm still not done with this object. Please hold on, don't collect your object because I'm still working with that.
Gotcha.
And it could be opposite, when a native world could create an object, now managed world think, oh, it's not done still there, so let's hold. Even if we don't have other references to this object, it could hold it. It could keep it not as a garbage.
Gotcha.
And I could explain it with this small little image of immortal objects. So don't create immortal objects. Those are bad. And
sounds cool, but don't do it. Okay.
And it happens when you have these two worlds. Native, you see on the right native view controller and views. And from the left, you have managed world, C# with view controllers and views. Whenever you don't know what is happening on the native world, you cannot collect it from this world. I'll show you one example how you can do that. So in my example, I'm creating, I want to add here a small little button save, and just want to close the view once user hits that. Let's assume that this save button will also do some saving logic, database or HTTP calls, whatever. It's just not going back, and it actually executes some additional action.
Okay.
As details of this button, we send in the handler. This handler is saying that please close this controller.
Looks perfectly legitimate to me.
Yes, we will introduce a memory leak.
Okay.
You're bad.
Oh.
It will, unfortunately, and it's a common pattern.
Yeah.
We don't have any static event like here. We don't have any singleton like here.
Yeah.
We're just keeping this button here. This is just a local item. Okay, James, now we created a button and we want to add it to our navigation view.
Okay.
So we set in it through the navigation item. Also don't use any static references, nothing like that. And just it. Now we have this up button and let's start the profiler.
Okay. Yeah, and again, super similar pattern. I create a button, add a button,
Yep.
and then I pop the view controller. It seems
Have a
normal.
delegate which doesn't use any external or static references and doesn't pass any reference from our controller.
Gotcha.
Should work fine, right? Let's see. So profiler will show the objects created at the very beginning, and I'm going to start tracking them at the very beginning.
Okay.
So I'm hitting snapshot right now and filtering to my objects only. Again, very common pattern to troubleshoot memory issues, just to see only my objects. Then I'm going once there. This is my button. You see, this is a new control. Nice little application. We have this in memory, which is true. We expect that. And going back, let's hit one more time, and one more time.
One more time, because
and
I don't
one
know.
more time.
Okay, it's still there.
And one more time.
Okay.
It is still there. So let's open it a lot more times. Let's also close it different way, going back, going save. It's actually basically doing the same.
Yeah.
And let's hit the memory snapshot one more time. And oh wow, we have 5 instances of pages hanging there in memory. And if we have a huge image there, it will have a lot of memory.
Got it.
So that's very common pattern because it doesn't obvious that you have a memory leak here.
Yeah.
The issue here is that UI button item actually holds to some native resource. It's bound to native resource. And if we don't clearly say that I no longer need this button, you will introduce this immortal object.
Gotcha. So how do I solve this then?
To solve that, let's use our disappear event and do something with our button.
Okay.
So we have 2 options. We could use either use clicked event and subscribe and unsubscribe, but we will be back to our first item when we subscribe without unsubscribing. Let's do something more interesting. We'll just dispose the button.
Yeah, I like that. I'm done with it, right?
Yes,
Okay.
we kind of say in managed world that I'm done with the button, please dispose it. It's not obvious because lots of views and wrappers in Xamarin iOS has this dispose method and you don't really know whenever you should call that. So it's an interesting case. But let's do that. And let's run. That's the only action I've added since the previous application run. I'm starting the profiler and doing the same use case, going to track the objects from the very beginning and make sure they are disposed.
Very cool. So this is nice. So you could have, like you said, instead of passing that entire action in, you could have just kind of similar to how we did connectivity, subscribe, unsubscribe, that would have figured it out.
Yeah.
But in this case, you already did it, so you just dispose of it.
That's right.
Cool.
Yeah, because we don't expect it to be unsubscribed. We don't have, it's not kind of a subscription. We just pass in and delegate inside of local object. In case of notification center, it's kind of subscription because we pass in local object into some static instance or singleton. In this case, we're just using our local resources. We do not expect a memory leak.
Gotcha.
But unfortunately, I can see this pattern a lot and people getting into these situations. So let's do the same trick. I wish it could save this data. So we have just one view controller and delegate. Let's hit save. Let's hit save. Let's go back. Let's actually stay at details page. Hit memory snapshot. And we see one. Let me click it a few more times. We'll talk about that. So we have just one instance here. I click save, click snapshot, and it disappears.
It's gone.
Okay, memory leak fixed.
Very cool. Nice.
Immortal object was killed.
Very cool.
Yep.
Alexey, this is awesome. So very simple. Look at your events, but also kind of look at how you're passing these actions around. And even I wouldn't even think about that button, to be honest with you, because the constructor is like passing this thing.
Yes.
So very cool.
I would also recommend to use it to our developers to use it more often, to like once a week, every sprint, and then to see the memory usage. You can see it as a UI test run. It shows this little memory working set. So you just see over months if it grows or not, and if it grows, you probably have a memory leak.
Now you showed iOS. Now what about for Android? Is there any specific other tools that you can use?
It's a great question because Android, everything we talk about iOS applies for Android.
Gotcha.
You just have different tool for Android profiler, native profiler called Android Profiler. It is really cool. It shows you a lot of information, but you still have to use it with the Xamarin Profiler in conjunction because of managed world and native world.
Gotcha. Makes complete sense. Well, it's cool that there's great tools available no matter where you're at, iOS, Android.
That's
and
correct.
Then you can go and debug. And then honestly, just looking at some of these, I'm pretty sure my code does a lot of bad stuff. So when I stream next, it's going to be all fixing my memory leaks.
Okay.
Very cool. Anything else, Alexey, you want to talk about?
That's all for today.
Awesome. Well, thanks everyone for tuning in. Alexey, thank you so much for showing off all this stuff.
Thank you, guys.
I love
Thank
it.
you, James, for letting me.
Absolutely. And make sure that you check out all the show notes below. We'll put all the source code, all the links for all the documentation down there. You can also go to aka.ms/Xamarin Best Practices for the entire series. So make sure you subscribe today wherever you're watching right now. I'm James Montemagno. This has been The Xamarin Show, and thanks for watching.
Thank you, guys.
Hey, James here. Just wanted to check in and thank you for watching this video. Now do all the things that you know you want to do, such as like, subscribe, and ding that notification bell to become part of the notification squad. While you're here, check out all these awesome videos that I've already recorded. Click on that thing. Click it. Watch it. Do it.